Hi everyone, in last video we have gone through DC series motor, and in this video we are going to learn about DC compound motor. We'll not go into much detail, just will briefly know about this DC compound motor, and just briefly we'll discuss about these graphs because this is not much important and I don't wanted to waste your time also. Let's discuss in a very crisp and short way. This is going to be a really very short video. While coming to this compound motor, this was nothing but a combination of series motor and shunt motor, which we have discussed in our last two videos. So in our first video we have gone through DC shunt motor, and in the second video we have discussed about DC series motor. So if you haven't watched that video, or else if you wanted to understand this DC compound motor, please go and watch that video. Only then you will be able to understand this DC compound motor in a very easy way. Okay, so this DC compound motor is further classified into two types, that is nothing but your cumulative compound motor, and then a differential compound motor. So this cumulative compound motor is nothing but like cumulative, which is nothing but like it senses like an addition. So here you should add. What should you add? See here, firstly let us go through this diagram. This is the diagram for DC compound motor. See, firstly here you will have a supply voltage, let us consider it to be V, and then here you were having your shunt field, and then here you are having your series field as well as an armature connected to this. These both were connected in a parallel. See here, it is a combination of a series and as well as the shunt motor. Okay, here this is your shunt field, and then this is your series field, and here an back EMF EB is produced, which is exactly opposite to the supply voltage given. So this DC compound motor is nothing but a combination of series and shunt, and it can start even at no load, whereas in DC series motor it should not start with no load, because the motor will run dangerously at very high speed, which is not at all preferable. But while coming to the case of DC compound motor, we can start this even at no load. And in this cumulative compound motor, this flux produced by series adds flux produced by shunt field winding. That means the total flux will be equal to flux produced by this shunt field winding plus flux produced by this series field winding. Okay, and the characteristics of this compound motor will be in between, that is like a combination of series motor characteristics plus this shunt motor characteristics. Okay, and this flux due to this shunt field which is there, due to this shunt field winding, the flux whatever we get is like constant. Okay, will be constant, and this shunt field winding, though it is constant, this shunt field winding is shunt field winding have more flux than the series field winding. This is one of the point to remember, and these were the graphs. So this is your graph between N and torque. These were not much important, but just remember. And this was a graph between your torque and Ia. See, just using those formulas, those two formulas which we have discussed in our previous video, that is torque is directly proportional to flux into Ia, and N is directly proportional to Eb by phi. We can derive these graphs. That is for the N and torque, the graph is in this way, and whatever the graph we get for N and this torque, the same continues for the N and Ia, and this is the graph between your torque and Ia, and this is how your graphs look. And this was all about your cumulative compound motor. And you have another type which is nothing but differential compound motor. There is no greater difference between this cumulative and differential. It only varies here, that is your flux will be equal to flux due to shunt field winding minus flux due to series field winding. There comes the difference. So in the case of this differential compound motor, your flux will be flux due to shunt field minus flux due to series field winding. Okay, and this differential compound motor was not used much, so this was not at all required. It is rarely used. So why? Because here the speed will be more, and speed increases when the motor is loaded, and the torque also reduces. So since your torque reduce and the speed increase, that was like rare phenomena, right? Nobody wants to run at a very like dangerous high speed, right? So we will not use this much. So we should not go into detail regarding this. And where we use compound motors is nothing but wherever we require high starting torque and relatively constant speed. High starting torque was like in the case of series motor, whereas constant speed like in the case of shunt motor, which we have discussed. This means this compound motor is like a mixed characteristic of series and shunt. Okay, these compound motors are applied where high starting torque and relatively constant speed is required. Okay, and the examples were, these were used in rolling mills, pressers, elevators, stamping machines, shears, and heavy duty conveyors. And that was all about these video. And here these examples were also like a combination of a series and a shunt motor. That's it for this video. And if you have any doubts regarding this topic, don't forget to ask me in comment section. Definitely I'll respond to every one of your doubts. Feel free to ask your doubts. Okay, thank you for watching, and our next video will be on transformer. So next video will be going to discuss about what is transformer and about the windings on that. And in after that video we'll be going to discuss about the cases like transformer when it is at no load and when it is at load. How does a transformer behave and what is the working principle behind it? So stay tuned for the further updates. Thank you for watching and subscribe my channel for more videos.